My name is Reagan, and today we're going to be doing Experiment 20, Qualitative Analysis. This experiment will teach us how to determine which ions are in a solution, or which mixture of ions is in a solution. After this experiment, you will have learned 4 important skills. The first being how to perform a spot test. The second is about which solubility rules will apply to a certain solution and what solubility rules are. The third is how to balance chemical equations, and the fourth is how to use a flow chart in qualitative analysis to determine which ions are in a mixture of an unknown solution. So qualitative analysis means that we're going to determine which ions are in a solution, as opposed to quantitative analysis, which tells us how much of an ion is in solution. So to do qualitative analysis, we're going to be using a number of reagents that will make different colors when added together that can show us which ions are in a specific solution. It will also show us, for instance, if it forms a precipitate or if a mixture of two ionic solutions does not form a precipitate. So to do this, we also need to understand solubility rules. Solubility rules are a set of rules that we have that tell us which combination of ions will be soluble or insoluble in solution. That is, which ones will remain in solution or which ones will form a solid that will fall out of solution, which is called a precipitate. So some of these rules include, for instance, that all group 1A elements are soluble in water. This includes any compounds that have sodium or potassium in them. Another solubility rule is that all nitrates are soluble in water. It doesn't matter what the cation is, if it's a silver nitrate, if it's a potassium nitrate, it doesn't matter. Nitrate is soluble in water. And then a last rule is most chlorides are soluble in water, such as sodium chloride, which is table salt. However, some chlorides, such as silver chloride, are not soluble in water, and that's one of the things that we'll demonstrate today. So before we begin, we need to make sure that we're safe in the lab and that we've taken care to wear our personal protective equipment. You need to make sure that you're wearing closed goggles, not just safety glasses, gloves, a lab coat that's buttoned all the way up, and that no skin is exposed below the waist. This includes wearing long pants and closed-toed shoes. And finally, make sure that any long hair is tied back. It's especially important in this experiment because we'll be using a centrifuge. So this lab has 3 parts. We'll be doing the first 2 parts in this video, and for the first part we'll only be doing one of the ions out of the 5 ions that you will be doing in your lab. So for this part, we will need 5 ionic mixtures. One is silver nitrate, barium nitrate, lead nitrate, nickel nitrate, and iron nitrate. I will be showing you the spot test with silver nitrate only. You will need a well plate for the spot test, and then you will need 6 reagents. So the first one being 0.1 molar hydrochloric acid, the second being 1% potassium thiocyanate. The next is 0.1 molar potassium chromate, 0.1 molar ammonium hydroxide, 0.1 molar sulfuric acid, and finally 0.1 molar dimethyl glyozyme. So our first example is using silver nitrate and potassium chromate. So first, you will add a couple of drops of silver nitrate to the first well on your well plate. You will only need a couple drops, but for the purpose of this experiment, we're going to use some more so that way you can see what reaction takes place. So after adding the silver nitrate, you can then add the potassium chromate. So as you can see, a brownish red precipitate formed when we added the potassium chromate to the solution. So combining these 4 ions, silver, nitrate, potassium, and chromate, we can come up with 2 new compounds, either potassium nitrate or silver chromate. We know from our solubility rules that any group 1A element is soluble in water. That's every element in the first row of the periodic table. So this cannot possibly be potassium nitrate. Likewise, any compound that contains nitrate is always soluble in water. So this compound that has formed must be silver chromate. So now that we've made a mixture of silver nitrate and potassium chromate, we're going to fill up the remaining 5 wells on the top row with silver nitrate. the next reagent that we will add is potassium thiocyanate. Add a couple of drops to well 2, and as we can see, a white precipitate forms. Next, we will add ammonium hydroxide to the third well. Again, we have a white, yellowish precipitate that forms. Next, we will add DMG to the fourth well. As we observe it, we see that no reaction is taking place. Next will be hydrochloric acid, which creates another white precipitate. And finally, we will add sulfuric acid to the final well. And again, we see that no reaction has happened and no precipitate has formed. Make sure you write down your observations in the chart on page 268 in your lab book. It will help you later identify which ions are in which mixtures as we do the second part of the experiment. Next, we will make a mixture of the 5 ions that we are using today into one test tube. So to do so, we're going to add about 5 drops of each metal nitrate solution into this test tube. We'll start first with silver nitrate. Next, we'll add iron nitrate, and lead nitrate, barium nitrate, and finally, nickel nitrate. After you've finished adding each of the 5 solutions, you will have about 1 to 2 milliliters of solution in your mixture. So you'll want to label this test tube as A. This will help you keep things in order as you separate the liquids from the solids into 5 separate test tubes. So the first step, as you follow your flowchart on page 268, is to add 1 to 2 drops of hydrochloric acid to this test tube. So as you can see, a white precipitate is formed in our test tube. We will now need to separate the solid from the liquid by using a centrifuge. So to make sure that the centrifuge is balanced, we need to add about the same volume of liquid in another test tube as we have in our first test tube. We will then place them in the centrifuge directly opposite one another, and that will allow them to be balanced. So if we open the centrifuge, we will see that it has 6 tubes where we can add our samples. Some centrifuge might have these adapters that are smaller tube holders. You can remove them if you need to. So now we can place these opposite one another so that it's balanced. We can then close the lid and set the time for about a minute or 2. So to stop the centrifuge, you can turn the dial to off, which will stop the timer. You want to make sure that you don't open this until it has stopped on its own. If you do open it and put your finger in there, you might hurt yourself. So now that it's stopped, we can open the centrifuge and remove our samples. As you can see in this one, the solid has been forced to the bottom and to the side. This will allow us to separate it and then continue with our experiment. If you still see white precipitate floating around in the liquid, you can centrifuge it for longer, or again, try not to disturb it because it may move around and be resuspended in your test tube. So now that we've separated the liquid from the solid, we can very carefully decant the liquid into a separate test tube. We'll label this test tube B. So if you're careful, you should have just solid in this test tube and the remaining liquid in this test tube. So to the test tube with the solid in it, we're going to add about 30 drops of deionized water. This is somewhere around 3 to 4 milliliters. Adding the water will raise the pH, which will allow lead chloride to go back into solution and will leave only silver chloride at the bottom. We can now heat this, which will promote the lead chloride to redissolve into solution. So to test tube B, which contains the liquid that we separated from the first test tube, we're going to add 9 molar ammonium hydroxide to this to make it basic. As you can see, we now have a red precipitate. This is iron hydroxide. We can then separate it using the centrifuge like we did before. So after centrifuging, we can now remove our test tubes. We're going to need to separate the liquid from the solid. Again, very carefully pour the liquid of this part into a new test tube. Take the test tube that has the red solid in it and add about 5 drops of nitric acid until the red precipitate has dissolved. You may need to stir this with a stir bar or shake it a little bit to get the solid to dissolve in the nitric acid. If you need to, you can add more nitric acid to dissolve the solid. So now that it is dissolved, we can label this test tube C and set it aside for later when we will do spot tests to verify that this is indeed iron. So the test tube that we poured the liquid into can be labeled test tube D. To this test tube, we can add the 0.1 molar solution of DMG. We will know if this contains nickel because it will form a pink precipitate. Ensure that this is well mixed by using a stir bar or by mixing it manually. So now we will centrifuge this one again and then separate the solid from the liquid. This test tube only has 2 ions left in it, and we know one of them is nickel. So now that we have finished centrifuging test tube D, we can pour off the liquid into a fresh test tube. You may have a slight pink hue to the final test tube. You can centrifuge this again to remove it, but for now we're going to continue. It's not going to affect our final analysis. Once we have removed the solution from the hot water bath, we can then pour off the liquid into a new test tube. This will keep the solid in this test tube, which we know is silver chloride. So once we've removed this from the centrifuge, we can now decant or pour off the liquid from the solid precipitate that is then centrifuged to the bottom. We know test tube A contains silver chloride, so we can set that one aside. We can now move on to test tube B. We suspect that this test tube contains iron. We can do spot tests to make sure and follow the pattern that has been written out on the grid in your lab book, or we can add potassium thiocyanate, and if a blood red color forms, we will know that it is iron. Because this dark red color has formed, we know that this one contains iron. We can move on to the next test tube, which we suspect contains lead. What we're going to do is to add sulfuric acid to this to see if it forms a white precipitate. Once we add sulfuric acid to this, we will indeed know that it is lead. As you can see, a white precipitate is formed upon addition of sulfuric acid, so we know that this one does indeed contain lead. This test tube we have already determined contains nickel because it's the only one that forms a pink precipitate upon addition with DMG. This final test tube contains what we think is barium. To determine that it is barium, once again, distribute some of the solution using a pipette into a well plate and then check it with the different reagents to confirm that it does match the pattern that is found in your lab book. What we will do though is add sulfuric acid and make sure that it forms a white precipitate. As you can see, upon addition of sulfuric acid, a white precipitate is formed, and we can indeed confirm that this is barium. That concludes Experiment 20, Qualitative Analysis. Please ask your TA for any help if you need assistance with the lab or with the problems in your lab book.